Step inside a high-tech organic fiber facility and discover how agricultural byproduct is transformed into one of the world's strongest natural textiles. For decades, the banana pseudostem, the massive trunk left behind after fruit harvesting, was considered mere waste.
Today, inside this sprawling 50,000 square foot processing plant, that waste is the gold standard for sustainable manufacturing.
From the rugged, water-heavy raw trunk to the silky, high-tensile threads used in currency paper, textiles, and automotive composites.
This video reveals every step of the engineering marvel. This isn't just farming, it is precision industrial process. This facility processes over 200 tons of raw material every single day, turning an environmental liability into an economic asset. Prepare to witness a transformation that blends heavy machinery with delicate fiber science. Welcome inside the factory.
The journey begins at the receiving bay, where the logistics of raw material handling present the first engineering challenge. The journey begins at the receiving bay, where the logistics of raw material handling present the first engineering challenge.
Banana stems are notoriously heavy, comprised of over 90% water. A single stem can weigh between 6 to 80 pounds.
Upon arrival, the stems are subjected to a rigorous initial inspection. Unlike fruit processing, where aesthetic
Technicians look for signs of pest damage or excessive dryness, which could compromise the tensile strength of the final fiber.
Any stem that doesn't meet the density criteria is diverted to a secondary line for composting, ensuring that only prime material enters the main production flow.
Before any mechanical processing can occur, the stems must be thoroughly cleaned. They travel up an inclined belt into the primary rotary washer.
This isn't a gentle rinse, it is a high-pressure industrial shower. Nozzles blast them with recycled water. The water used here is part of a closed-loop filtration system, reflecting the facility's commitment to zero-waste operations.
But the real challenge comes when the clean stems exit the washer. A banana stem is actually a pseudostem, tightly packed layers of leaf sheaths.
To extract the fiber, the stem must be deconstructed. The stems move to the splitting station, where the geometry of the plant is analyzed.
Here, a pneumatic guillotine system, guided by laser sensors, slices the cylindrical stems lengthwise into 4 distinct quadrants.
This exposes the inner core, which is softer, and separates it from the fibrous outer sheaths, which are tough and rigid.
The sorting process here is critical. The outer sheaths contain the coarsest fibers suitable for ropes, while the inner sheaths yield finer fibers.
With the material washed, split, and sorted, the preparatory phase is complete. The waterlogged plant. We now enter the decortication hall, the heart of the factory. This is where the physical transformation.
These rollers exert a pressure of nearly 1,500 pounds per square inch, effectively squeezing out a significant portion of the water instantly. If the blades are too sharp, they will cut the fiber. If too dull, they won't remove the pulp. The margin for error is less than a millimeter.
The kinetic energy flings the wet green pulp downward. This byproduct will later be converted into fertilizer.
At this stage, the fibers are still green-tinted and coated in sap. To prevent oxidation, which turns them brown, they are immediately treated.
they are plunged into a neutralizing bath. This continuous washing channel uses a mild, biodegradable enzyme solution to target pectin and gum.
The enzymes attack the glue that binds plant cells. The bath is temperature controlled at exactly 45 degrees Celsius to optimize activity.
How do they ensure quality? Sensors analyze the water's viscosity in real time. If gum levels rise, fresh water is automatically cycled in.
Once neutralized, the fibers pass through a hydro extractor. Two massive rollers squeeze the mats, reducing moisture.
The fiber is now cleaner but still damp. It enters the multi-pass drying tunnel, which uses reclaimed heat from the factory's generators.
Fans circulate hot air at 80 degrees Celsius, gently evaporating moisture until the fiber reaches a precise humidity level of exactly 12%.
It is a dramatic transformation. What entered as a heavy green trunk has been reduced to its structural essence, light, fluffy, and strong. But the real challenge lies ahead. The fiber is currently a chaotic mix. To meet export standards, before aggressive refining, the fiber rests in a conditioning room to regain flexibility. We move to the refinement floor. Dried fiber bundles are fed into the carding machine, which functions like a giant mechanical hairbrush. Thousands of fine steel wire teeth tease apart the clumps. The goal is parallelization, making sure every strand lays in the same direction.
As the fibers are combed, shorter strands, known as tau, are separated. These aren't wasted.
The long fibers are condensed into a sliver, a continuous, untwisted rope. It is now ready for the
The fiber then undergoes hackling, a finer combing process that splits fiber bundles down to individual filaments for a softer touch.
To aid spinning, a fine mist of vegetable oil and water is sprayed onto the fiber.
This lubrication reduces friction and prevents static electricity during high-speed spooling. Hispanic male technicians perform tensile strength tests, stretching the fiber until it snaps to ensure it meets the industry standard of 29 grams per denier.
If a batch fails the strength test, the entire production line stops. Engineers must backtrack to the decortication stage to adjust the blade pressure.
Mills. For high-end artisanal applications, some fiber is diverted to the knotting department. Here, tradition blends with
Automated knotters or skilled workers join individual lengths to create continuous spools without twisting, preserving the fiber's natural ribbon-like structure.
As we near the final stage, the chaotic pile of green waste has been fully transmuted into Manila hemp.
In the packaging zone, the loose, combed fiber is weighed into precise 100-kilogram batches and loaded into a vertical hydraulic baling press.
The press exerts 50 tons of force, compacting the fluffy fiber into a dense rectangular bale. However, precision is key. If the bale is too tight, fibers crush. An automated system secures the bale with high-tension steel bands.
A robotic arm applies a label containing the batch number and quality grade, allowing the end buyer to trace the fiber back to the specific plantation. This factory produces over 10 tons of finished fiber daily. From here, bales are loaded.
But the engineering doesn't stop at the fiber. Remember the washing stage? The wastewater and green pulp are piped to a neighboring biogas facility.